Hello, today we are going to be talking about the life cycles of stars, and we are going to be specifically talking about the three paths that stars can take in their lifespan depending on their initial mass. So if they have a lower mass, if they have an average mass, or if they have a very high mass. And so each of those things are going to lead to different outcomes within the star's life. And so I am going to be drawing and demonstrating those to you now. A star's life cycle is determined by its mass and its temperature that it started as. Stars form from gas clouds in space. These interstellar clouds are very dense and the gravity starts to shove the gas closer together. Eventually, the gravity gets so intense it causes the cloud to condense. Gravity is so strong the core collapses, except something is keeping it from collapsing. Nuclear fusion. The gas is spinning extremely fast at this point, reaching temperatures of millions of degrees Celsius inside the core of the cloud. Nuclear fusion. The gas is heated up so much it becomes plasma. It causes the hydrogen atoms to get excited and collapse, fusing into helium atoms. This gives off some energy in the form of heat and light. Nuclear fusion is the process by which stars burn. Two hydrogen atoms fuse to make one helium atom, plus energy. When stars start to fuse, they go from being protostars to main sequence stars. This is the phase that the majority of stars spend the majority of their lifespans in. The mass of the star in the main sequence is the same mass as the gas cloud it formed from. So, for example, interstellar cloud of one solar mass will turn into a star with one solar mass, and an interstellar cloud with half a solar mass will be a star with half a solar mass. When the main sequence star starts to fuse most of its hydrogen in its core, the core becomes unstable. The outer layers of the star expands. It is expanding and cooling, which is why this turns into a red giant star. Main sequence star, the hydrogen runs out, the layers expand. It's the same star, but it's just a red giant. While a star is a red giant, it can start fusing other elements, helium into carbon, etc., etc. Depending on the mass of the star, it will have different outcomes in its life. There are generally three paths. Low to average mass stars up to 10 solar mass. Average high mass stars 10 to 20 solar mass. And high mass stars 30 to 40 solar mass. In low to average mass stars, which are up to 10 solar mass, we start off with an interstellar cloud. This turns into a main sequence star. The main sequence star will expand into a red giant star. The gas will shed in a planetary nebula, and then the core remains as a white dwarf star as it cools down until theoretically it will turn into a black dwarf star. Average to high mass stars, so 10 to 20 solar masses, you have an interstellar cloud that becomes a main sequence star. This goes into the red giant phase. Then, because it's so massive that it has so much mass, that when it sheds its outer layers, it actually collapses into a supernova. So the core is collapsing. What's left of the core is the neutron star, which is spinning extremely fast. It's extremely dense, hot, and small. It has a very high mass and a very small volume. High mass stars, 30 to 40 solar masses. You have the interstellar cloud. This will generally turn into a blue giant on the main sequence because it has so much mass to begin with. This will then turn into a blue supergiant, which will then go into a supernova where the core will collapse. However, instead of being held up by neutron degeneracy pressure, the gravity is so strong that it actually collapses completely into a black hole where nothing, not even light, can escape. There's infinite gravity and infinite density. This is the final path that stars can take. Thank you for watching my video. Please subscribe if you like science and space.